You're welcome to Computer Science class. My name is NC Joshua, popularly known as Oracle. I'll be taking you physics for the Y class, preparatory class. We're looking through semiconductors. Now we're looking at possible questions that can be asked in semiconductors, but I have to give a kind of rush overview so that you can have an understanding of what semiconductor is. Now, what is semiconductor? Before we can define what is semiconductor, you ought to know that there is somebody before a semiconductor and there is something after a semiconductor. Now let's take that for instance. We have something like this called a conductor. Now if we have a conductor, then here is an empty space, then we have an insulator. Now if we have it to be like this, so it means if we are defining what is a conductor and what is an insulator, it will basically be in terms of their electrical property. Electrical properties. So if we are checking it based on their electrical properties, therefore it means the electrical property of a conductor, there is an electrical property of a material that exists in between that of a conductor and an insulator. Then what becomes such a material? Such a material becomes a semiconductor. So we can boldly say that a semiconductor is a solid which has its electrical property in between that of a conductor and an insulator. Now, if you ask yourself a simple question, what is a conductor? A conductor is that material that does what? That conducts electricity, while that is the insulator is that does not what now conduct electricity. Why will a conductor conduct electricity? Why will an insulator not conduct electricity? Now it means that there is something called, we have to look at something here called resistance, meaning there is an opposition to the flow of current in here that is much more higher than that you have in here. So it therefore means that the resistance in conductor is low, but that in insulator is high. Take note, the resistance of a conductor, the resistance of current flow in a conductor is low, but the resistance of current flow in an insulator is high. Hence, there is a flow of charge, meaning there is a flow of electron which brings about electricity in conductor, but there is no flow of electron in an insulator. I will explain it further again because they can ask you such questions in OBJ segment in semiconductor. Now I can do something like this. I'll put it like this. One of them is overlapping. I'll come again, do for this, then I'll come and do for this. I'll call this part the conducting band, then I'll call here the valence band. Now, this to this, that's for A, this to this for B, then this to this for C. Where here is the conducting band, here is the valence band. Here is the conducting band, here is the valence band. Here is the conducting band, here is the valence band. Now you see that this guy is the intermediate between this and this. That's B is the intermediate between A and C in terms of structure like. If you observe it, you see that it's overlapping here. The conducting band overlaps the valence band. Then if you check the second part, you see that there is a narrow space between the valence band and the conducting band. Then if you come over to C, you see that there is a wide gap between the valence band and the conducting band. Hence, what can you say? It means that this valence band is, this particular A is 2 meters, YB is to semiconductors. Please take note of this diagram. Very, very important. It's to semiconductors. YC is to non-metals. Now, what can be said here? Very important. It means that I can say that in a semiconductor, I want to redefine a semiconductor different from the one I defined the first based on their electrical property. Now, this gap between the valence band, the conducting band, and the valence band is called the forbidden gap, or the forbidden energy gap. It's called the forbidden gap or the forbidden energy gap. Therefore, I can boldly say that a semiconductor is that solid which has a narrow forbidden energy gap. A semiconductor is that solid which has a narrow forbidden energy gap. Now, watch this now. There is a possibility for electrons to jump into the conducting band for conducting electricity. There is a possibility for electrons to leave the valence band into the conducting band for electricity to be conducted. So it means there is an easy moving or movement of electrons here. Hence, there's going to be electricity. Hence, there's going to be electric current. Hence, the metal will conduct electricity. Why? Because electricity is brought about by movement of flowing of electrons. Now, if you consider this part, there is an inability for electrons to jump from the valence band to the conducting band. Hence, this particular non-metal, which are non-metals, have no ability to conduct electricity. Why? Because the gap between the valence band and the conducting band is too large for electrons to jump and be found in the conducting shell for electricity to be conducted, or for it to conduct electricity. But for a semiconductor, please take note of this, at 0 Kelvin, everything I'm saying, you have it in your PDF file so that you can sit to read, but I have to explain to you very, very well. At 0 Kelvin, a semiconductor is just an insulator. At 0 Kelvin, a semiconductor is just an insulator. Take note of that question, very, very important. But when there is an increase in temperature, when there is an increase in energy, what happens? There is a possibility for electrons to jump from the valence band to the conducting band. Hence, for it to conduct electricity. Now, remember, we want to see something very important that can be asked in question. Now, what is that we have to see? Remember, we talked about the conductor has a low resistance to current flow, but the insulator has a high resistance to current flow. Now, why it means here there is an intermediate between that of the conductor and the insulator. Now, we've come again to say that there is an overlapping of the conducting band and the valence band. Hence, there is no forbidden gap between both of them. But here there is a narrow forbidden gap in a semiconductor, while there is a wide forbidden gap in in a non-metal or an insulator. Now, I hope you understood all of this. So I have defined semiconductor in terms of electrical properties, and I've defined it in terms of forbidden energy gap. The gap between the valence band and the conducting band is called the forbidden energy gap. Now, if you come to metals, which we can say conductors, you understand that the resistance of metals is directly proportional to temperature. What does that mean? It means that increase in temperature increases resistance. Increase in temperature increases resistance. Now, if increase in temperature increase resistance, therefore, and you know that resistance, please take note of this, very important. And you know that resistance is said to be an opposition to current flow. Now, if temperature increases and resistance increases, it therefore means that the opposition to current flow in metal increases. Now, remember, we're talking about increase in temperature. We're talking about increase in temperature, not at room temperature. No, we're talking about increase in temperature, or just at 0 degree Kelvin. No, we're talking about increase in temperature. Now, if increase in temperature increases resistance, hence resistance is an opposition to the flow of current. We are not saying that the opposition to the flow of current when temperature increases, it's what now? It's high in metals. Hence conductivity. Hence conductivity becomes low. Resistance is high. Conductivity becomes low in metals. I'll say that again. Increase in temperature increases resistance. And when resistance is increased, it means that what? Opposition to the flow of current has increased. And when opposition to current flow increases, we are not saying that what now? Conductivity decreases. Now, if we've said that, then now I want you to now understand that in semiconductor, very, very important. In semiconductors. Now, in semiconductor, as temperature increases, resistance is inversely proportional to temperature. What does that mean? It means that as temperature increases, resistance also decreases. As temperature increases, resistance decreases. But in conductors, as temperature increases, resistance increases. But in semiconductor, as temperature increases, resistance decreases. Hence, if temperature increases and resistance decreases, now here resistance decreases, therefore conductivity does what now? Increases. Now, Wyatt has asked to explain the conductivity of a semiconductor based on temperature. That's a nice answer for such a question. Now, let's look at this. What are some of the things you need to know about a semiconductor? What are some of the things you need to know about a semiconductor? Mind you, at the end of this class, there's going to be a test for you to go through. If you watch, before I proceed out of this part, I would like you to understand again that what semiconductor can be defined based on what my electrical properties, and it's that solid whose electrical property is intermediate between that of conductors and insulators. And we went further and we said that semiconductors, that they is that solid which has a narrow energy forbidding gap between the conducting band and the valence band compared to that of metals and what now and non-metals. Then we talked about in terms of temperature that increase in resistance, increase in temperature increases what now? Resistance. And when resistance is increased, opposition to current flow is what now? Is increased. Hence conductivity decreases. But remember I said at 0 degrees Celsius, a pure semiconductor is an insulator. Now we have what we call charge carriers. Charge carriers. Now, what are charge carriers? Now I'll do this very fast. In metals, we have in metals, we have in non-metals. Okay, we have in metals, we have in liquids, we have in gases, and we have in semi-conductors. We have in metals, we have in non-metals, we have in gases, and we have in semiconductor. Charge carriers in metals are electrons. Take note of this question. Very good. Charge carriers in liquid are what now? Are ions. Charge carrier in gases are electrons or ions. Then charge carriers in semiconductor are holes and free electron. Holes and free electrons. Holes and free electrons. These are the charge carriers in what now? In a semiconductor. Holes and free electrons. Now, what about a semiconductor again? Now, what I'm doing now is I'm giving you properties of semiconductors. What about semiconductors? A semiconductor can exist as a crystal lattice. A semiconductor can exist as a crystal lattice. They are crystal lattice. And another good example again about the semiconductor is that they have covalent bonding. They have covalent bonds in them. Semiconductors, they have covalent bonds in them. Then another properties about the semiconductor as we can look is that now if you watch this, the conductivity increases with what now? With decrease in what now? In temperature. The conductivity increase as temperature decreases, as temperature increases, resistance decreases. As temperature increases, resistance decreases, and conductivity does what now? Increases. That's very, very important to know about a semiconductor.